Добрый день, уважаемые участники конференции. Я рада приветствовать вас в этом.
I'm glad to welcome you all here in this room. Today we will have 3 presentations, 2 more first and then a coffee break and then this last one. I'm glad to welcome our speaker, Camille Islamov, Technical Director of CTE. Hi everyone. Thanks, Yelena, for your kindly introduction. Since we don't have much time, I will try to express as much as possible, to tell you as much as possible. Let's discuss a little bit the development, and my presentation is devoted to our vision how to use such wonderful extension as common table expressions. And then in the attachments, it's possible to use ORM, can use storage procedures, both opportunities, and we will discuss more the situations when stored procedures are used or when SQL statements are designed directly without ORM. Why we do not use ORM in our projects? Because we have competencies in SQL. We don't have a need to wrap SQL around with something else. That's why these advantages of ORM are not needed. We don't see any big value in them. But we see values in working directly without ORM, to work directly with SQL, because we use as much competence as possible and we use the opportunities of WMS. Here in Postgres, we have opportunities which we get separately from CTE, from Postgres, and the also CTE efficiency can also be deployed in application applied to functions. We use options of CTE and we implement them in page SQL or in SQL functions. Since we've been using it for a long time, we already created our own ideology, which we are going to discuss with you today. For example, if we take data exchange between CTE queries within one SQL query, there is an opportunity to transfer a lot of information within one SQL operation, and it's possible to save a lot of resources. What CTE can give us when SQL is placed in the forefront of our business logic. It means to change business logic of a business query without any tricks with parameters. In this way, we can show to Postgres or to other DBMS what we would like to take in the beginning and what to do next. This is like an optimization without optimization itself. Another opportunity of CTE is an alternative to temporary tables, which are not widely used in Postgres, as you know. But one of the functionalities of the temporary tables is a set of data in the form of table, which can be given by one or multiple CTE blocks. They give an opportunity to join, to merge, which gives us Postgres additionally. It was also mentioned in other presentations. It would be a wonderful option to use delete, update, insert. We use insert sit config, and in this case we return either inserted or fresh data after upgrade. And it is possible to build up this chain one after another and to get to return a wider business logic, as it's shown here in this example. Some CTE blocks create preliminary data, some CTE blocks search it in a simple way, in a complicated way. In the same chain, some blocks can use the business logic, can update some data, and in the output we can get either updated data or preliminary data, previous data. If, for instance, we use opconfig, there is excluded construction, structure which can give new data, or there is a structure which is called dot and name of the table. So in one CTE query we can see both old and new data, and this gives us an additional opportunities to pack the whole business logic into this chain. We do not set this task to wrap as much backend operations in one query, in one chain, but we succeed in many cases. When we do not succeed, we can use several chains. And some service, auxiliary functions, logging of input data or logging of results, inputs, or both. Well, these are the opportunities which allow to provide necessary data exchange. Upconflict is the most usable opportunity, the most useful opportunity in our case. If we speak about functions, SQL functions, we use IPL SQL and PGP SQL. These are the functions which are written on pure SQL and provide enriched CTE chains, and they allow to fulfill non-linear scenarios of the business logic, and they provide certain limitations, and in this case they are used within PGP SQL. One of the conveniences here which we receive from CTE is especially the transformation of the input data. It happens very often that arrays, big arrays, several arrays come with the parameters, and it would be really convenient to transform these arrays to tables and then transfer these tables along the chain and do something with them. If we speak about PGP SQL functions, here it's very convenient to use arrays as variables. Declare, then variable, and then comes the array. Such variables combined by a statement gives us a classical table which can be joined and which can give additional opportunities, of course. Besides that, what else we got from the in-depth implementation of CTE queries is when a lot of information comes with JSON. So at the initial stages, JSON variables were classically transformed, and when we used JSON record as very wonderful feature, the type which was also mentioned, this structure wrapped in a CTA query allows to get startup tables from JSON, or if it's JSON containing arrays, it allows to get just tables directly from JSON without any explicit transformations. The majority of applications work with JSON now, so this approach was integrated in a wonderful way into the existing infrastructure, and it allowed to get rid of very much codes from functions and concentrate on the direct business logic through data processing using CTE tables. And in the output, it's also quite convenient, and Oleg Portunov already mentioned that. It's possible to wrap JSON to key value format or JSON arrays, or combine both. It should be all wrapped into CTE query, allowing to form as a result one JSON, and we then can select it and can get some useful output. These are the examples how to work without JSON and with JSON structures using CTE chains. It allows us to unload significantly the code. We didn't have to test it under load, which will give us loads on the CPU in timing, but maybe, well, if there's less code, it obviously would give us something, and maybe sometime later we will test it too. Just a few more words about the deployment and bringing up JSON to record, either using unnest if it contains array elements, or without nest. Anyway, such processing in one transaction allows to get the resulting line, which was given for the very first JSON to record statement. If we indicate these arrays, we can make distinct or take the next chain, and if we don't have to see the array, we need one small piece from JSON in the beginning, it all can be done within one SQL operation, and so it can be further transferred to other CTE chains, which would then add an additional business logic and make some processing. On this page we show more details and we show more steps of JSON transfer through CTE chain to the internal logic. Well, let's say there are two groups of functions: the functions which get data, get card or get account, and there could be only logging in terms of changes, just request of information, request of goods, one CTE chain which checks the whole business logic, whether this account has the right to see this data or make some mathematical transformations, and log-based CTE chain which places JSON to the log which was in the input, and then in the output there will be just select JSON if we speak about SQL function. If this is the function which is not for viewing but for changing the data, for storing data about transactions, here of course we can have more chains. Some chains prepare data, some other chains take part in the controlling business logic, controlling rules, controlling rights, and then creation of the resulting JSON and also logging maybe. So the difference is there in changing SQL function and PGP SQL function, especially PGP SQL functions are good to be used when logic starts to be ramified. Well, branching of CTE chains are written one after another, but in every block we can refer to any other block, introduce some conditions, and the branching logic can be realized. In this case, it would be easier to take PGP SQL functions, to populate it with massive variables, and to rule it out in a more classical way. But in this case, CTE queries play their role in optimization. In some way, we say which data should be taken in the first place in more optimum way, how to join them, just to save the resources. Here we see the description of the concept. If the whole business logic is wrapped in one SQL function, it's clear that if we are not allowed to use some policies for SQL queries, we can replace the whole logic which is initially provided by the application, and we can relocate it to this SQL chain and to get an opportunity to implement the whole business logic of DBMS using one query. Here, if we speak about PGPL-SQL function, which gives more functionality, the CTE chains allow to optimize working with big arrays, and that's what we already mentioned. Once again, just the summing up information. How can the interaction go between CTL chains? In our projects, these relations were formed without our intervention. Some good usable paradigms which are moving back and forth between functionalities are able to implement these functions, and so at the output, as a rule, we get the resulting JSON, and in the input we have JSON also. As already mentioned, it can be with arrays or in a classical form with a few parameters. And now, what are the benefits in the context of a business application when we imply that we use the vicinity of business logic to data and we relocate processing of the whole information to the DBMS side? When we use it, as mentioned, to optimize SQL queries, in some cases without CTE, and in some time many heavy queries will not look beautiful. And the second point, where it is convenient for the business logic, when the results of the same CTE chain can be used in other chains with their own if, wheres, and other conditions. And it's also a caching element within one SQL, of course, within one SQL request. But the majority of functionality of SQL tables allow us to close this functionality. And what are the opportunities? It's written here. Complications and constraints contain development of this chain only. Some skills are being generated in course of time. The example of this chain, I didn't write the code here. I just hope that the majority of you understand how it looks like. This is an organizational structure, logical structure. For example, we have an incoming JSON. We wrapped it up with JSON to record. We transformed something, made some conclusions. We joined existing tables with the identifiers. If we found the identifier, the chain is going on, and in this record then we have all this data. If the identifier was not correct, the chain is being cut and JSON comes in the inner form. It has nothing to join with. The logic is different. It can be processed in an outcoming final JSON. For example, it's possible to join virtual select error based on the conditions 1 is equal to 1 with the results of this chain. If there is no chain, so this first error block is coming up and it is delivered to the output. What does it give? What benefit does it give for the application? First of all, it's an opportunity to redistribute responsibilities. If there are competencies which work with DBMS, with backend, who like to work with data, so it's possible to distribute them using these opportunities, even if some ideology prohibits to use some procedures. As a result, we get an opportunity from the managerial point of view to redistribute risks and to get the outcome the lesser amount of applications and to the database, queries to the database. If initially we plan the business logic from the point of view of minimum queries to the database and not to bring over some business operations to backend and to execute them inside the chain and to get some profit out of this activity. And at the outcome, it allows, as a result, to save some resources and to get the result in more optimum way with smaller code. And of course, it's necessary to remember that there are no opportunities to use directly codes. Some third-party solutions should be used, and we implemented some of these third-party solutions at one of the projects. And so the conclusions, which are said many times.
I think there is a possibility. Please look at the paradigm, and maybe you can make some tests and see how much profit does it get, how to minimize the SQL queries. And this is it. Questions, please. Thank you very much for your presentation, Camille. Further. Thank you. It was very interesting, but I paid attention that you make two JSON and backwards. No, only once. In and output. And SQL, this standard, have you chosen this one? Why should we do that? This is to take it from JSON, you make the table and work with the table further on. This is one of the JSON table, it's called. Yes, we use JSON table. It's not being realized in Postgres. When I write JSON, a JSON table pops out. We don't use that. We do not have this incoming data, but we have QL in JSON or some arrays. And with big arrays, it's very well run. It's running very well. And I forgot to mention one peculiarity. In the logic in the chain, you have some. During one of the steps, you said, "Oh, I added some data in that step in the table, but it will not be there." And you know why? Because in RCC you didn't make the commit yet, and that's why you have returning focuses or some focuses of creating extra chain, taking it from somewhere else. So you address to these chains. This is when we had a couple of situations like that, and it helps a lot to work with such arrays. Next question, please. Thank you for your presentation. It was very interesting. As a web designer, especially with JSON, do you take it from authorized sources? No, it's a web application from Python. Web application, simple like that. You cannot trust this data. No. This is front. That is what is front is operating with. This is not interesting to us. So we get something at the back end from the front. So naturally, JSON is not created on JavaScript, but in application. But still, there's an intermediate application, PHP validation. Well, it's encrypted, so it's used in order to to try it. If there is a validation in JSON or in verify. So if it's breaking into some parts, it's ready to create SQL in JSON. It's a bit late to use it. But if it comes from authorized source, then it will be a good profit. On some of the projects we have PHP, when we have many variables, and before we address it to the base, and with JSON, I forgot this command, but there is command that is transported and we call it into the array. It goes to the base, and then output we have TKO. If you build up the arrays, then there is no problem. So I think it's +1 more operation for JSON. So first of all you realize, and then you check, and then realize to the base again. I think it's encrypted in PHP on the max safe fast. It's faster if we do it ourselves. If it's encrypted in Postgres, and it's encrypted in all the backends, so I cannot optimize it any further. JSON is being implemented like that. Thank you. Any more questions? All the CTE blocks, is there minimum range between the CTE blocks, or is there some library of these blocks? Does it exist, or do the developers write the queries again and again for the CTE blocks? Maybe I use the terminology, but this is just a query. So the first part of the preparation of the incoming data, it will look the same, correct? So every time you need to, yes, JSON construction comes in, so we need to receive the line from the table from JSON. So every time the developer is writing it, so you didn't generalize it. No, we didn't have time yet. So for the hierarchy of CTE or recursive, have you addressed to those ones? In this context, it doesn't matter if it's cursor or recursive. So if it's just a query for IT and recursive, you didn't have those. No, they can be built in, just they will not be implemented separately. If there is a need and hierarchy, then you can use the array. Thank you. Any more questions? Thank you for your presentation. You give the description of CTE from the positive point of view. Everything's great. They make your life easier. Don't you think there are some disadvantages in CTE? No, I have mentioned that in the beginning, that you need to get used to that paradigm. That's you need to additionally train the programmers. There's no overhead on that. Overhead in CTE, it has to be relatively small. They said about the performance, and they say, please do not get involved with CTE too much, because it gets one of your Postgres resources. You mean the memory from the server? Well, the thing is that each block, if you don't call it CTE, you need to call it with a separate query if you are talking about the classical paradigm, and if it's, you need to use this select function. So how much memory you use, and so a general select, like, and CTE select. We haven't make the research on that, but our ideology is to make it faster. So we make the calculations in thousands, and we see how much load is on the processor. If the memory is good enough, then we don't follow this path. So if the memory is overloaded, we haven't made any notice on that. So we use this paradigm in a few different projects. We only see the profit working with CTE. We have some Oracle background, and we've been working with Oracle for quite a long time, so our mentality, I can say that we have Oracle mentality. Thank you for your presentation. I thought it would be about something else, that the code becomes simplified and interesting, closer, something like that. But my question is the following. If we have on each step of CTE, we have some arrows management. I know how I will write it in the procedures, but if we use CTE, like cases like when I need to do something else, I can add it to the same column, so the same CTE. But in this case, the code will look ugly. Don't you think when you work with some special cases and you try to put it into one CTE and something horrible happens? This is why I had a separate slide with a description of two. This one with, not that one. So with PGL function, well, first of all, you need to read some initial data and translate the parameters, and then you need to send it by two paths. How would you keep and storage the first part? This question can be answered the following way. The prehistory is the following. Since we, as I've said, we have experience with Oracle, the code was written by us with cursive and closer to Oracle methodology. Why we moved to that paradigm? Because this code was repeated and you need to put it in the register and compare the figures. And when we had this possibility, we started sort of like rolling back. Inside of this chain, if there is a very serious if, so then you need first is the reading the parameters and then logging it in the register. We use this PGSQL. If you cannot put it into one line, one SQL function, then you can use the usual PG function, so you can select the queries or maximum steps that do not load to the whole chain. Thank you very much, Camille. It was a very interesting presentation. Myself was very happy to listen to this presentation. Thank you very much and goodbye.